Welcome to qnawire.
So we have the free body diagram for part A here, and they're asking us to find the force with respect to x. So we can say that the sum of forces, or the sum of the torques from the point A would be equal to 600 newtons times x plus 300 newtons times 2.5 meters. And then minus the force of B times 5 meters. And we can just say here is a 600 Newton force, and then here we can say somewhere is the 300 Newton force. And we can say that this distance from here is going to be 2.5 meters. So essentially, here we're going to solve for a force of B, because we know that this is going to be 0 because this is in rotational equilibrium. So we can say that the force of B is going to be equal to 120x plus 150. So as you move farther and farther away from the point A, we know that force of B is going to be increased. Let's do the sum of torques. We know that from point B, and this is going to be equal to 0 because, again, we have a rotational equilibrium. And this would be equal to the force of A times 5 meters minus 300 newtons times 2.5, and then again minus 600 newtons. And here it would be 5 minus x. So that would be the distance from B. And when we use this, we can say that force of A equals 750 minus 120x. So in order to graph this, we simply need to we can plot these both in the same graph, and essentially the force will be on the y-axis, and then the x will of course be on the x-axis, and these would be your two equations for the line. So when we want to graph this, it would look something like this. So this would be the graph of force of B and the force of A graphed on the same graph. Again, your force in newtons is your y-axis, and your x in meters would be your x-axis. Now for part B, they want us to find the x with which the bar tips. So we can use we can use the formula for the force of A or the formula for the force of B. I'm going to use the formula for the force of A, and I'm going to say force of A equals 750 minus 120x, and we're going to set this equal to 0. And this is going to give us x equaling 6.25 meters. Now, this essentially means this would be a distance from point A, and this critical distance would essentially mean that this is going to be the distance from point A before the bar tips. So essentially, x would equal 6.25 meters. If it does not equal 6.25 meters, then essentially the bar is going to tip and it won't be in rotational equilibrium anymore. Now, here they're saying that for part C, this would be your free body diagram for part C, and they're saying that for part C, let's just say that force of A equals 0 newtons. So let's say the sigma tau, so the sum of torques evaluated at point B will be equal to 0. So again, this is in rotational equilibrium. And this would be equal to F of A, 7 meters, plus 600 newtons times y minus 300 newtons times 4.5 meters minus y. And we find that y is going to be equal to 1.5 meters, and this would be the location of point B, and this would be again from right end of beam. So this would be the distance such that we have rotational equilibrium if the force of A suddenly were to break. So this term right here is going to be equal to 0. That is the end of the solution. Thank you for watching.